Taking a minute to get the live stream going, but we will get started momentarily. Well, it's not even 7 o'clock yet anyway, so that's good timing. All right. I guess I'm still sharing. Okay. Okay. All right, everybody. Welcome to the 8th week of Apple app development. I'm glad that we have everybody here with us. We're going to go ahead and get started. This week is week 8 on Structs and Enums. I have Taylor back with me, and Becky will be hosting, so our usual crew. So before we really get going, I want to see if anybody has any questions from the previous content before, like I said, we get moving.
All right, I'm not seeing any hands at the moment, but as soon as there are some, I will let you know.
All right, now raise your hand if you have any questions about previous content in the course. Okay.
Oh, wait. I thought I saw a hand. Yes, I did. Margaret.
Hey, Margaret.
Okay, it always takes me a while to find that raise my hand thing. My question is, when you were doing the let's see, the I forget what it's called, but the one with the double question mark.
Optionals.
No, it was an optional, but it was a specific type that I can't remember the name of it right at the moment. So you had a print statement, say, where you had print the say that the one person's name, I think it was Taylor, and then it had two question marks, and then it had like someone else in quote, which was the default.
Mhm.
The default in case, I guess the way I looked at it, in case that other value wasn't given.
Correct. In case it's nil or empty.
Or empty. Now, is this set up because, say, you might be, say, scanning data or bringing in data and somebody forgot to fill out something? Or is this in case, we as writing the software didn't write it right?
Well,
Or this, in God we trust, or why did they set this up this way? I just can't figure out when to use it. So do I have to put one of these with every print statement that I'm printing a value on a variable value?
no, if you remember, you use one of those if you want to use a default value if the variable that you're using is an optional. If a variable is declared as an optional, then using a default value is an option. It is one out of those 4 options that we talked about.
Oh, all right. Okay, I remember now. All right, thank you. Sorry.
No, you're fine. And if you remember, default values have to be the same type
Yes.
as the variable that you're expecting input from. And the reason why we do this is if we're getting input from like a network, like a call to the internet, like we're pulling down data, we want to use one of those. We want to use a way to make sure that what we get back isn't empty, and if it is, how do we handle it if it's empty?
Got it. Okay.
Yep. So using a default value is one way to make sure that a variable has content, or that we do something based on if there's nothing in the variable.
All right. Thank you.
Mm-hmm. Any other questions?
All right, I'm not finding any other hands, and I don't see anything in the chat.
All right. Again, so optionals took us quite a while to finish last time. I don't foresee this one taking as long. So we're going to go ahead and get started, unless anybody has other questions that you'd like to ask before we get started. Okay. So let's talk about two different topics today. We're going to talk about a concept called structs or structures, and a topic called enums. A struct is a new kind of way of doing objects in Swift. And a struct, we're used to using classes and those kind of things, which we may talk about next week. But this time we're going to talk about structs because they are absolutely essential in Swift UI. And so that's the next thing we're going to talk about is enums. And enums are another kind of method for verifying data. So we're going to talk about that as well today. So I'm just getting my notes going here. And then we will begin. So structs are basically, when we're familiar with the basic data types. And, a basic data type might be a string. It might be a integer or int. It might be a Boolean, bool, or things like that. Structs let us create our own type. And the reason why they're useful is we can have structured data. A struct is it's short for structure, and it's a way to create your own custom data type in Swift. You could think of a struct as a blueprint for creating objects that represent real world things. We used to use classes for that because you would create the class and have the like the method, the properties and the methods, and you could inherit and other things like that. We'll talk about that more next week. So some examples of some things that would be a struct would be like a contact, name, email. Is it a favorite? Is it a favorite contact? Like pinned. A book, title, author, page count. Has the book been read or is read? That'd be a Boolean. A task, title, priority, and status. Those things would be a struct. A location, latitude, longitude. You can store those as structs. Swift gives you built-in types like integer, string, and Boolean, but structs let you define your own types with properties and behaviors. So like properties, like their own variables and methods. So why use a struct? A struct is used when you want to group related pieces of data together and possibly add behavior, which are methods to it. Some examples. So let's create some structs. So I'm going to go into Xcode and I'm going to create a struct. So I have a new playground page open and I'm on line 5 and I'm going to write struct, all lowercase. And we're going to call this, let's see, what do we want to create? What kind of a struct do we want to create? We're going to make a contact, just like we talked about. So we're going to say struct contact space left brace, left curly brace, new line, and we're going to put var name, or we could even do var first name with a capital N colon string. And technically we could make these optional, so we could say if they can be empty or not. But we're not going to do that here. We're going to do var last name colon string, var email colon string. So we're specifically saying what type of variables that these are inside of this struct. And var phone number colon string. And string is with a capital S. Okay. And then we're going to have our right brace and those kind of things to end our struct. Now, this is the definition, and we can create models. We can do all kinds of stuff with this. And it's a lot more clean. It's a lot cleaner than creating a class and have to have initializers, getter and setter methods, and things like this. Okay. So then we can basically add data to our, we can create instances by saying we could create a friend, var friend equals contact left parentheses first name colon space double quote Michael double quote comma last name, I can last name colon double quote Doey's double quote comma email colon double quote my email address double quote comma phone colon double quote 5551212 and we do a double quote right parentheses and then we have declared we should have declared our struct, but I wrote something wrong, so let me go back through and see what I did. So what did I do? Incorrect argument labels in call. Name. So apparently I did something and corrected it. Okay. So that is how we create an instance of a struct. I think I just had some argument labels. So then I could do something like print left parentheses double quote my friend's name is backslash parentheses friend dot first name, my parentheses space backslash left parentheses friend dot last name right parentheses period. And if you notice, we didn't use everything in the struct. We just used some of the things in the struct. Okay. So what we did was, in our output, what we're going to see, if I can bring my output up here. There we go. So what gets printed should be, and it's not being printed, so what's going on here? Xcode is having a minute. There's no errors in the file, so why isn't it printing my output here? Just a second. Let's see. Where is my page explorer? Not sure why Xcode isn't showing what it's supposed to show. Let's see. There we go. For some reason, it opened another window that was on top. So let me close that window here. Okay. So it still says we don't have any issues, but it is not printing content. So, oh, there we go. My friend's name is Michael Doise. Okay. So in a lot less code, we have created a struct, which is basically our class. We have created an instance, and then we printed the content. This would have taken a lot more code if we used classes, okay? And you can make data relate to each other and other things as well. This is how Swift does databases with data storage through SQL. You create your stuff in structs or classes, and you store it in this format. So I could have another instance here, var second friend equals contact, and then left parentheses first name colon double quote Taylor double quote comma double quote last name no, that is not correct. Last name colon space double quote ARNDT double quote comma email colon space double quote let me put in an email here. quote, comma, phone number, colon. And I still cannot type. Phone number, colon, double quote, right parentheses. So now we have two structs, or two instances. They are the same contact. They're using the contact structure, but we have two different instances. So now I can print left parentheses, double quote, my second friend is backslash left parentheses Taylor no first second friend dot first name right parentheses and their phone number is backslash second friend dot phone number right parentheses. Oh, that is incorrect because I put a period after it. And I missed the first parentheses. So we used different data for the second print. So my second friend is Taylor and their phone number is, and then it gives the phone number. So we use different pieces of data from the struct. So when I'm using the information from the struct, I'm using different pieces of information from that instance that we created. These are called properties. So the other thing to keep in mind is we can, if I say var age colon int, then that's going to cause all of this to fail. Because now these are incomplete. But let's see what happens if we make age optional. It's fine. Why is that? Why is it fine if I made age optional? Well, it's because age is not a required field. So technically, I could come up here and make all of these optionals by adding a question mark at the end of all of these variables. So you don't need a first name, you don't need a last name. Nothing is actually needed to create this struct, technically. Now, we're going to get warnings because we're, printing stuff and we may not know the value. So again, we could come and force unwrap because we know the values, or we can use default values or the other techniques that we saw in the last class. Any questions about what we've done so far?
All right, you've got two hands. So Margaret, I don't know if your hand is up again or if it's still up from last time. And then Jim.
I guess I'll go ahead and jump in. I am still really confused about the difference between a struct and an object. To me, an object is a struct that has routines, and I'm trying to figure out if that's what's going on here or if there's something else.
So
what is it that makes a struct different than an object, not just a subset of an object?
Jim, we were taking bets if you were going to ask that question. In Swift, a struct is value-based, whereas objects through classes are reference-based.
You even prepared an answer. Okay. That's perfect. Thank you.
I need to be prepared for that one. So to kind of break it down for everybody else, if you assign an instance of a class to another class in Swift, you're basically referencing that other class. If I assign a struct to another variable, it makes a copy. So structs are lighter weight, they don't require as much code, and they're value based. So it's kind of like you're creating your own variable type. And both classes and objects can be written to have properties and functions. Structs are just a bit lighter on how the program's executed. Okay. Any other questions? Margaret, do you have a question?
Her hand isn't up anymore, so I think it was just a remnant from last time.
Before.
I don't
Okay.
have that ability to put hands down when people forget, so.
No, I'm good. I'm sorry.
Oh, you're fine.
Thank you.
You are fine. Okay. Any other questions before we move on?
No. Oh, yes, Fenton has a question.
Go ahead. Fenton, if you have a question, go ahead.
Can you hear me okay?
Yes, now we can.
Okay, thank you. Value base, I'm confused. Can you go through those basics again?
Sure. So first, kind of like we declared a function, we have our struct to say struct content where we define our structure. And then we added properties to it. So like name, like first name, last name, those kind of things. Then we create our instances of our structure that we created. So like first friend or friend, then second friend, and then we printed out different things from those instances.
Yeah, I got that. At what point are any of these value based versus other things that you were talking about earlier? Just so that I can classify those things a little bit better in my head.
Can you repeat the question there?
You mentioned the word value based. Not sure what that is, and how do you associate what the structure and the definition of the instances? Would any of these be value based versus class that you were talking about earlier?
Sure. So let's review that. I think this should work. So I'm going to create some new lines between our where we created our instant. Okay. So let's, you know how we have var favorite fav color :string, right? So we have we're just saying fav color :string. We're defining a variable of type string that's called fav color. Well, I can create I should be able to say var new contact :contact. And because this is a variable type, unlike classes, because this is a variable type, it is totally legitimate because we're saying it's a type of contact. Now, technically, your struct should begin with a capital letter, so I did that wrong. So I would make sure your structs begin with a capital letter. So capital C in contact. So I'm just correcting my mistakes here. So again, we have var fav color colon string with a capital S in string. And we have var new contact colon contact. Because contact with a capital C is a value that we've created. That's the beauty of structs. And a
Now,
struct
contact in my mind right now is a structure that you created.
Mhm.
I wouldn't call it object because you told me that it's not an object.
It's not the same as class.
It's a variable type you just created, isn't it?
Correct. Correct. But we
Okay.
create instances of. So when we talked about objects, that's more classes, which is different from structs.
I guess the word class threw me off a little bit here. Did we go through classes before?
We have not. In fact, we're going to do that next week, if we even need to. Swift UI classes are not as needed as structs. Struct is kind of the newer way Swift handles object-oriented programming.
Yeah, so this is value based, you said?
Yes.
What is value based?
So your value-based means that every new variable that you create is basically, from my understanding, value-based means every new instance is a new piece of memory. Even if I were to say, let's see, if I have var new contact equals, let's say I equal it to friend. Okay. I can then change the content of new contact, and it would be totally different. Even though I said this equals friend, it's a new value. It's a whole new variable. Now, if I did create a class and I said, and I did the same thing, new contact equals friend, then I would be making a copy. But this is making a whole new value. So it's a lot more unique. You make sure that your code is lighter weight. You have unique data, and it's a lot safer to work with.
Yeah, I suppose I can think of these variables after you constructed the structure. Each variable that you define is an instance and is also a value.
Correct, because they are new values. And we'll compare more of that next week as we go into classes. Something else I can do, guys, I can do var contacts colon left bracket contact. Any idea what that does? Oh, capital C, that's needed. So if I put contact in brackets, what should that do? I still didn't do
You
a
create a
capital C.
collection of
And-
contacts, huh?
Yes.
You've got some raised hands, Michael.
I'll get to those in just a second.
Sure.
So one of the things that we can do is we can have, like Jim said, a collection of contacts. So
And a collection means
an array.
an array. Yeah. Okay.
So I can load data in from an API call and then load it into a collection of structs I could create structs based on that. So we could use like a for loop or other methods like that to add those. And I'll get hands in just a second, but I wanted to show what this looks like. So we have var contacts colon friend left bracket friend comma second friend. And so now we can use our array commands and like our indexes and all those things that we talked about to get that instance of the individual contact. So this is how a lot of apps do this. This is how a lot of apps get large amounts of data and store it where you can load data. I mean, databases use this. You can create tables by doing this. Structs are a very powerful way of storing information in Swift. Okay, other hands that are raised.
All right, so your hands are Melissa and Jim.
Hey, Michael, I'm unmuted already.
Yep.
So, I think you answered my question actually in your just demoing, but so you can have different variables in the same struct, correct?
Yes. Yep.
Okay, that's what I wanted to make sure. That's really cool because I didn't know like how customizable it was, but like I said, as you were demoing, I kind of got my answer. So thank you.
Mm-hmm.
And I have 2 questions. You said that Swift is using structs for object-oriented programming. So do structs have methods and inheritance and so on built in as well?
They have methods, but if you still need to use inheritance, you still need to use classes.
Okay. And then I was gone last week, so I apologize if you covered it then, but you keep emphasizing capital letters. I don't know what that's about. Can you explain why capital letters are important in certain data types?
So, like if you in Swift, if you use a data type of string or int, they all begin with a capital letter. So capital I in int.
All data types start with a capital letter?
Yes.
Ah,
Even
okay.
bool, capital B.
Okay.
So we do that with our structs as well.
Okay. That's good. Thank you.
Mm-hmm. And again, do we have any other questions?
I don't believe so. No, I'm not seeing any other hands. Nothing in the chat.
Okay. So structs can also have methods. You can add functions called methods to structs, just like types in any programming language. So we can have different functions in a struct. So one of the things that we can do is we're going to go back up to our struct. For me, that is we're going to get after line 10, and we're going to create a new function. And I'm going to make 2 new line characters, and I'm going to put func say hello, and left parentheses, right parentheses, space, left brace, and we're going to write print, left parentheses, double quote, hello. And then just like other languages, backslash left parentheses, contact dot name dot first name right parentheses, exclamation mark. So I apparently wrote that wrong. And let's see how I wrote it wrong. Because I figured that that would work. So what we would actually do. Oh, it's easier. I made it more difficult. You don't have to have the contact part. It assumes that. So you would just write first name from my understanding. Yes. So because we declare the variables above the function, it just says hello / left parentheses first name. And because we're using that inside of the block, then it knows to use that. So let's go below friend, which now for me is line 17. I'm going to go to line 18. I'm going to type friend dot say hello. And so in my playground, it'll say hello, Michael, exclamation mark, because I called that method from within the instance. Okay. Any questions there?
All right, so far, no hands. Oh, Jim has a question.
Go ahead, Jim.
So it sounds like if you're writing a method inside of a struct, all the variable names have to be fields within the struct.
Correct.
How do you, or can you reference variables from outside the struct?
I believe you can. Let's find out. So I'm going to go outside the struct and I'm going to put var outside string equals double quote some text here double quote, and inside of my struct, and I'm going to go inside of that function and I'm going to write print left parentheses. I have a short memory. I already forgot what it was. Our outside string. So no, they cannot be unless you do something to allow that.
I'm thinking there might be some syntax that makes that possible, but I don't know we'd have to look it up. I was hoping you might know.
You would need to add main actor to your struct. So it's a macro called main actor. So before your struct, you would write @ main actor. It is a threading issue. Which is fascinating. I didn't think you would have to do that. It has to do with the new Swift syntax for async await and things like that. So you probably don't want to do that. You probably do not want to reference global variables inside of a struct like that.
Yeah, I get that, except that I think it'd be improbable if as code gets bigger that all the things you want to do in a method will be from fields that are in the struct.
Well, you basically, like in Swift UI, the things that we're going to be doing, structs will be throwing data around through other structs.
Okay, I mean that makes sense.
Yeah.
So okay, all right.
Okay. So that's an example of a very basic function here. We could do return types. So let's create a function called read age. So we're going to do func read age, left parentheses, right parentheses, dash greater than, int with a capital, we're going to return a string, and then we're going to do space, left brace, and we're going to write return, double quote, return space, double quote, your age is backslash left parentheses, age, right parentheses, period, double quote. And because it's an optional, we can do age question mark 0 for a default value. So that makes it not have a warning. So we have return, your age is backslash left parentheses, age question mark 0, right parentheses, period, double quote. So that function returns a string of your age. Now, what we can do here is we can say, well, one of these we need to give an age to. So we're going to go to second friend, and we're after the phone number, we're going to do comma age colon. Let's just make up an age for Taylor. We're going to say 25. Okay, so that makes it valid. And so after that, we're going to go down to our print statements. So line 34, and we're going to say print, left parentheses, double quote, not double quote. We're going to do print, left parentheses, second friend dot read age, left parentheses, right parentheses, and then right parentheses again to end it. And so we have a return statement in that print statement. And I have a typo on second friend. So let me fix that. Second friend dot read age. And it has your age is 25. So we can use return values in those functions as well. Okay. So why are structs so important? Well, we're going to get to that later on today. Okay. And there is more to do with structs. I don't know that we're going to do that today just because it is a lot of material. And so you can do our typical, you can have expressions that can mutate structs. So you have to, if you want to change a value in the current struct, you have to add mutable to the beginning of the function. We're not going to worry about that. So you use a struct when you want to use simple and lightweight data objects. When you want to create value type behavior, like copying instead of sharing. which is, sharing would be if you create a class, you're sharing data between different variables. Structs have clean code because you don't have to worry about init and all those things. Most Swift apps use structs for models and tasks and things like contacts and things like that. Structs are very much a new concept in Swift. The reason why they really weren't used much in app development until now is because much of building apps was based on Objective-C, which required classes. So that's why most of our code in UIKit and AppKit was all class-based. We will see structs a lot in Swift UI. So get used to seeing those. And do you guys have any questions before we move on to enums?
All right, I'm not seeing raised hands yet.
Yeah, I have a question. I just can't get to raise my hand fast enough.
No problem.
How would we know what structs are already there for us to use, like in the Swift?
That's a good question. When you create a Swift UI application, you have two structs. That's it, two. Two of them are created. Other than that, you have to create your structs. Structs are things you create, not that the system creates.
So you don't have a library of structs like you do for like buttons and things?
You do not.
No.
And in fact, I would venture to guess a button is a struct, an instance of a struct of type view.
Okay, that makes sense.
So you don't have to declare the struct, but you use that struct instance. Actually, that is exactly what you do. And we will talk about creating your own views and structs in our applications.
All right, thank you.
Okay. Any other questions?
Moment, I'm not finding any hands.
Okay. All right. So we're going to talk about enums this time. So let me change my playground page to enums. I've got a lot of playground pages. We're coming to the end of that though, guys. Oh, I know that I made one. Comments, enums. Just skipped over it. Okay, so enums are used for presenting a set of choices. They allow us to basically create choices that offer, they're short for enumerations. They allow us to create choices that are easier to use for error checking. So you could think of them as a list of options, and the value can be that the value can be. The way that we write them is we do. Let's see. We use the word enum, so instead of let or var, we use enum. E-N-U-M. Um, not weekdays. Let's see. Days of week space left brace. So we have enum space days of week space left brace, and we're going to use the word case. And after we have the word case, what we're going to do is put the different possibilities there. Okay, so we have case Sunday and Sunday, comma Monday, comma Tuesday, comma Wednesday, comma Thursday, comma Friday, comma Saturday. And these can be uppercase or lowercase, however you'd like to do it. And then you have your right brace. Okay. So I can then do, like, say I get a piece of data with the week, with a day of the week. So I'm going to put var some day equals double quote Tuesday, double quote. So this piece of data, we don't know. That could be empty, or it could be some other information or other thing. Then I can use a switch. Someday space left brace, and then I could do case point. Let's see. Let me make sure I'm doing this right. So you want to use a switch statement to check it. So you would do case space and then a period. Case Sunday space colon print left parentheses double quote welcome to Sunday double quote right parentheses. No, I'm doing this slightly wrong. Let's see. Day. So I am writing my switch statement wrong. So let me figure that out. Just to make sure I am doing this correct. So I'm looking at an example just to make sure I'm doing this right. Because you have to make sure that you have this correct. So they have a slightly different, they're using, the example I'm looking at has directions. So they do it slightly different. It creates a new. So using enums makes your code safer because you should not have invalid values. It's easier to read. When you use a switch statement to check with enums. And so then we would have to do some other things there. Let's see. So if we do, because we're comparing two different things, string and the other. So let's just do day case. So we're going to do switch space. I feel like the example that I'm having is not exactly flushed out. So let me get a better example of this, because the example that I was looking at was not fully flushed out. Because you can use also raw values, you can use a lot of different things. But you essentially can add, I do not know why that's not working. Switch. Let's see if we do. So we have days a week. And then if we do, I think we'd have to do, I guess they're all cases, and that's how that works that way. So let's see this. Let's do var some day equals day, because the types need to match, day of week dot Wednesday. So then we're going to switch someday. Left brace. Case point Sunday. Yep. Still giving me an error. Oh, switch must be exhaustive. Okay. So we're on the right track. So case period Sunday, colon, print, welcome to Sunday. And what I'm going to do is I'm going to copy that line and I'm going to paste it 6 more times. So we have 7 copies of the same case. So we're going to change these to Monday. So point Monday, point Tuesday, and I'll reread all this so that we have everything correct. So Thursday, Friday, and point Saturday. And then let me just change the strings. So Tuesday. Whoa, how did that happen? It kind of makes it jump sometimes. We have Tuesday, Thursday, Friday, Saturday. So then as our last case, we need to have case, and I believe it is, or is it default? I think it is. Let me just verify, but I believe use a either default or you just go through all of the options.
I think you just go through all the options. Sorry to
Yeah.
interrupt.
I think that's all that they want. Yep, that's all they want, is to go through all the different options. So we've made it exhaustive because we have case period Sunday, print, welcome to Sunday. Case period Monday, print, welcome to Monday, and so on, all the way through point Saturday. And the reason why, so let me go through the code again. We have enum days a week, left brace, case Sunday, comma Monday, comma Tuesday, comma through Saturday. So then we have var sum day equals days a week dot Wednesday. So at no point are we doing an if statement where we're checking one string against another string. Okay. So the reason why this is useful is because we are doing error checking. We are making sure that, so I could change this to Thursday, and it even makes sure I don't type the wrong thing. And now it changes my code to say, welcome to Thursday. So because I'm not directly checking one value to another, like manually, it's a lot better for error handling. Okay. Let's do another. We can even do what are called raw values, and let me show you how you could do those. Let's do case colors space left brace, and let's do no, it is enum. I wrote the word case. Enum space colors left brace case blue equals double quote blue. Okay. So enums have to have a raw type. So when you do this, your enums, if you're going to use raw values, they have to have a type. So the enum raw value type we're going to use is a string. So we're going to use enum space colors string space left brace, and that makes it all happy. Okay. So case green equals double quote green. Case red equals double quote red double quote. Okay. So then we can do something like var some color equals double quote blue. Now, from the way I understand it, we should be able to switch some color space left brace case colors dot blue colon, and then we're going to do print double quote, the left parentheses double quote, the color is blue. Case colors dot green colon Print left parentheses double quote. The color is green. Case colors dot red colon print. The color is red. And I didn't like that. Let's see. Case colors dot blue.
The keyword switched is spelled
Yes,
without an I.
Yep. Thank you for noticing that. So, pattern of type colors cannot match string. Yes, it can. Let's see. Let's see what my example says here. Colors dot green. So let's try taking off that. So it has to be colors. So that should work, and they should fix the switch some color. And so what we're doing wrong is the okay, so we have to do that slightly differently. So var some color, we cannot put equals. We need to do some color, and then what we need to do is say which this doesn't, I feel like the syntax here is strange. So we have to do colors, left parentheses, raw value, colon, double quote, blue, double quote, right parentheses. And that should have gotten rid of the errors because you're using raw value. But it still doesn't like it.
Sorry to interrupt. What is raw value?
Raw value means that you are you're telling it that's the raw value of, like, it's you're not using the enum or other things.
I mean, what's the difference between raw value and value?
Because value, let's see. And it wants it to be, the syntax is very strange here. You have to sometimes pull raw value to get it to day. They use they use the raw value to pull the raw information from that item. So okay, so I think that what it's expecting is it to be optional. So I think so you have to do if let some color to check if it's optional. So you have to unwrap it somehow is what you have to do. So let me go back to my original code. I used AI to try to do it. So we're going to see if we can force unwrap that. Because we know we're going to do switch some color. Yes, that did it. So in this case, we just force unwrapped it, switch some color, exclamation mark. And because we said some color equals colors, parentheses, raw value, and then the in quotes we have blue. So we're checking if we're saying that it's blue, and in our enum we're saying case blue, green, and red, but we didn't have to equal a string. It's very interesting. So enums are a way that you can basically say make this be error. The goal with enums, and I'll have the code on the platform because this is kind of more confusing because of the way I had to do things. Enums are a way that we can make sure that our code is safe and that if we do things that it works at compile time and won't fail at runtime. So if we know that there's a piece of data, we can use enums in our code to check that data and make sure that the data is going to be good at compile time without saying, if I have the word Sunday, I can check to make sure that Sunday equals Sunday and that some SUM day is not Sunday, right? Because the less that you have to use actual strings for checking, like if this is, Sunday, print this. If this is Monday, print that. The less you have to do with that and the more of the enumerations and on those things that you can use, the safer your code is going to be for errors. Now, again, what made it difficult here is that we're using a lot of optionals and raw values, and that will get a little hairy whenever we're pulling data from the internet. Okay, so keep those things in mind. So again, for this one, we have enum colors :string. So we're saying it's a string. So we're saying case blue, case green, case red. And so those are the hard-coded values: blue, green, and red. Then we're saying let some color equals colors, parentheses, raw value, double quote, blue. So we're saying that that is we're checking, like, say if I get data from the internet, and we'd have to use raw value to push that data in to check it by the enum. So that's why we have to use raw value. So, but once we get the raw value in, then we can say switch some color. And this kind of chant, because we know what the value is, we're saying switch some color, exclamation mark. Case dot blue, print, the color is blue. The color is green, the color is red, based on the cases. And we're exhausting all versions of the case. Okay. So these things we will use, both structs and enums, we will be using a lot in Swift UI. And there is a wonderful day on 100 Days of Swift UI. I would highly recommend that you check out, because Paul does a much better explanation of enums than what I could do. So I would check that out, but just know that that will be used in Swift UI. Structs more so than anything. You're going to see a lot of structs in Swift UI. So I want to take this time to see if people have questions about all of the content today.
All right, we do have some hands. So Fintan has a hand, and so does Jim.
Okay, go ahead.
I'll go first, Jim. So the differences between the two enums, why are they handled differently? One is someday you don't need to use raw value, and the other one, colors, you do need to use raw value. They're structured differently when you wrote it.
Yes.
Why are those two enums different?
One is like comparing apples to apples, and one's like comparing apples to oranges. Because a type string is different from the other types that we are comparing, right? So raw value is where you could compare different types to the enum types.
Still don't get it.
So if I say one string compares to another string, then that's apples to apples, right?
So is that the first case you have one string comparing to the other string?
Nope.
Some days?
Nope. So, because some days is not a string. It's a type of days a week. So days a week dot Thursday is not a string because we did not give it a type.
If it is not a string, what is that?
It is a enum type. So we created, it's kind of, think of it as almost like another value. So days a week is a type of variable. It's a type of enum is a type of variable with potential cases of Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So days a week is, we have var someday equals days a week dot Thursday. So then we do a switch someday. In the case that someday is Sunday, then we print welcome to Sunday. If the case is point Monday, a period, dot notation, we say welcome to Monday. So if I change someday to days a week dot something else, then it prints it. Now, if I change days a week dot Thursday to double quote Thursday, it's going to error. It's going to have a big error because it's not the same type. It's not apples to apples anymore. Okay. So because I'm comparing days of the week to days of the week as both types, they work.
Okay. I think I understand the top enum then. And then the bottom one is for sure string, right? Is that
Yes, because we have var some color or var colors colon string. So we're saying
you
our
force it
enum,
to use it as string?
yep.
Now I remember that if you didn't put this word string in there, it gave you some error. Why?
Well, I changed it to I had to change my the way I typed it because I had the wrong formatting. So I'm wondering if that works. Yeah. So we have case blue equals double quote blue, case green equals double quote green, case red equals double quote red double quote. So those are strings. So then we have let some color equals colors parentheses raw value parentheses blue. So if I change the raw value to green, and then it's checking point blue, green, or red. So then it says the color is green.
Mhm. And if you put the, just for experiment, if you put the sum color to be uppercase G for green, would that error out? It must, right?
Optional value. Oh yeah, no, it says it does error. Because we fatal error, unexpectedly force unwrapped. Unaccepted, I can't talk. Unexpectedly found nil while unwrapping an optional value.
Mm.
And
Yeah,
because we said it has to be that,
right.
then yeah.
But what if you didn't force to unwrap? Would
Well,
uppercase green?
there's several other ways we could have done that. We could have used the if let else like we had, right? We could have done a lot of different things in there. But that's just the simplest example that I wanted to use here.
Okay, thank you.
Mm-hmm.
All right, you've got more hands. So Jim and then Margaret.
So I am still, you totally lost me when you added data types to enums, and then this whole what's it called, the value, the value call.
Mm-hmm.
I don't understand why you would want to add a data type to an enum at all, right? The whole point of an enum is that it's just a list of possible values that a variable can have.
So the reason why you'd want to add a data type is if, like, you say you're doing a network call, like getting something from the network, like something maybe from XML or JSON,
You're reading a string, yeah.
and it's in it as a type of string. But you want to be able to compare that string to something in the enum.
Right.
So instead of having to do a if statement to compare it between string to string where there could be error, prone to errors because if you type something on accident in your code, the enum provides type safety to make sure that you wouldn't get that. So the only way you would have a problem is if it's a problem from the incoming source.
Um, um, so is the comparison case blind, or what happens?
It is not case blind. It is the comparison just looks at, so is point green the same as green as a string?
Yeah, but is point green lowercase, is point green lowercase and point green capitalized in two different fields?
Two different fields. Yeah, you'd have to check for both.
So it's really the field names are case insensitive.
Yeah, they are case sensitive. So
Case
like,
sensitive. Yeah.
yeah.
Wow. Okay. But why? Okay. But what if I made it a different string? What if I made it an integer instead of a string?
Well, then, as long as it's the same integer, it would be fine.
Can you say more about that?
So if I did, let's see. Let me write another one as a int. So give me just a second. I'll do that. So we're going to create another enum. Enum, let's see. What's a good word numbers :int space left brace, and we're going to say case ONE equals 1, case TWO equals 2, case THREE space equals 3, and you get the picture from there. So then we could do let, because we're not changing the value, let some number equals word numbers, which an extra D got in there. Word numbers, left parentheses raw value, colon, 2, right parentheses. So then I could do switch some number, exclamation mark, space left brace, case, 0.1, colon, space print. The number is 1. Case, .two, colon, print the number is 2. Case, 0.3, colon, print, left parentheses, double quote, the number is 3. Right, double quote, right parentheses. Now, what we're doing here is, again, you could do this in any way you want. I think you could even do it reverse, where your values would be, different things. But again, this still works. So we're doing hard checks. So the number is 2 is what we print out. So I did the same thing with integers.
Yeah. Okay. This makes more sense. So the comparisons are being done by the compiler rather than you having to do them. What's the point of the exclamation mark?
Force unwrapping for optionals.
But say more.
That was that's one of the 4 ways we can unwrap an optional that we covered last week.
Now, yeah, but these are enums, right? So how do optionals come into play here?
Because we're using a raw value, that's because we're using the raw value there, we're using the numbers parentheses raw value. It's making that as an optional.
Okay. Okay. All right. I think I've got what I can get for now. I have to go play with this one. Thank you.
Absolutely. Any other questions? So, well, real quick before we take any other questions, why this would be good for integers is maybe you have 3 or 4 different states that you're looking for from the internet. Like state 1 is order is ready, and it's put in JSON data as the number 1. Or we have state number 2, which is ready to cook. Like think of the or 5 values. Think of the Domino's pizza tracker. We could basically light up the pizza tracker based on an enum instead of having to have raw value like numbers. Like instead of just using the did I get number 0 back from the JSON? Does the value equal 0? I could do switch and then use point in the oven or point, so I could use enum for that error handling. So it works a lot better than just having to count on actual raw data. Okay.
All right, and Margaret has her hand up.
Go ahead, Margaret.
Okay, 2 questions. The shortest one is, what's a JSON? JSON? What's that?
JSON, JavaScript object notation. It is how most data is transferred on the internet through API calls.
Okay. Now
We could go through a lot of stuff on what JSON is, but I would just type into AI or ChatGPT, what is JSON?
JSON. All right. My second question is the enum considered this whole, the whole set where you have the enum and then you have the name and you have the parentheses, and is it the whole sequence of all this of all of this whole, I don't know what you would call it. It's not like a function, but of all of this procedure. Is the enum the whole procedure, or is
The
it?
enum is just where it has enum and then the name of the enum, maybe the type the enum might be, and then the possible cases that the enum could be.
Okay, so that whole thing, all those 4 things are considered the enum.
Right. So just whatever's in the code block for the enum.
Okay, thank you.
So for example, like in our first enum, we have enum days of week, a day of week, case Monday, Sunday through Saturday. That's the enum. That's all the enum is.
It's very similar to a switch then, where the switch is considered the whole kit and caboodle.
Well, the switch is the condition. The enum is where you check where you define what's possible.
Oh, all right. Okay. Thank you.
And I'm not finding any more hands raised.
All right. Well, anybody have any final questions? And we will probably cover, I have not decided if we're going to cover our classes next week or if we're going to jump right into Swift UI. I have classes in object-oriented programming on the schedule. So we may do that, and then the week after we'll jump right into Swift UI. So any last minute questions, even if it's about the work or the assignments or any of that stuff?
I have questions about stuff you didn't talk about today.
Okay.
I was looking at some Swift code in an open source project, and they were defining data types using a keyword called guard with it. And I don't remember us talking about that. So it looks to me like it's some way of conditionally assigning to a variable, but Can you talk about that, or is that
That was
something
one of the 4 types of unwrapping last week.
okay.
So guard let, or not last week, but the week before, guard let. So you're saying guard let variable name equals, whatever the optional thing that you're trying to get it to equal, else do a thing and return out of the function you're in if you cannot do it.
Okay. All right. I apologize. I need to go more thoroughly review what you did last week.
Yeah.
So let me do that before I ask any more questions. Thanks.
Yeah, we had force unwrap, we had default value, if let, and guard let are the 4 ways that we can handle what to do with optionals. Okay. Anything else? Okay. All right, everybody. Well, I think that's going to do it this time. We'll be back next week for more training, and I hope y'all have enjoyed it. And we'll see everybody then. All right. Thank you, guys.